Thank you so much. Okay, so we started recording the session. Welcome everyone to this session. Thank you so much for joining. The name of the session is about how digital twin can be used during a crisis like the pandemic we're living right now, what implications it has, and we'll share some insights from the case in Global Omnium in Spain, in Valencia, Spain. I was thinking, first of all, we should do a little bit of a round of introductions. I can start myself to break a little bit the ice. So I'm Pablo Calabuig. I am from Valencia originally in Spain, but I live in the US. I'm calling from New York City right now. I work for GoAigua. It's a digital company, a digital platform company that belongs to the IDRICA Global Omnium Group. We're helping water utilities worldwide adopt digital technologies like digital twin. And in particular, I'll share some insights about the case in Valencia, city of 1.5 million people, where we have implemented it some years ago. Next one, Michael Gardner.
Hi, I'm Mike Gardner. I'm the CEO of Akayax. We're a startup, a financial startup that is working to use data for financing water infrastructure. So we're kind of like bank software, but we also have a second product that is about data integration and sharing based on RESTful APIs. And so we use that in our finance product, but it also is a standalone data integration product.
Nice, welcome. Messen?
Well, I'm a data scientist from Vitens. I'm working with all kinds of models and data and just analyzing things every day, writing analysis and things like that. That's my ordinary work.
Great, thank you for joining. We have also Morten Groom.
Yeah, hi. My name is Morten Groom. I'm CEO and founder of a startup that has a platform creating automated digital twins to analyze wastewater flows.
Sorry, we have some background noise. If someone who is speaking could, yeah, that's fine.
Well, that's about it.
Yeah, that's great. We have Lakshmi.
Hi, are you able to hear me?
Yes, we can hear you.
Yes. So, hi, I work with the water and wastewater utility in Spartanburg, South Carolina, in the US. I'm an engineer, but I'm working in operations support. I'm relatively new. I've graduated a year ago with a master's in environmental engineering. So I've done some water and wastewater engineering modelings, but right now what I do is mostly analyze data, day-to-day operational data on the water and wastewater side, and kind of assist operators in making data decisions. So that's pretty much just setting my foot into the smart water thing right now.
Great.
So just curious to learn what this hype is about. Everybody's talking about smart water, and I recognize the need for utilities to move into smarter networks and use more IoTs and sensors. So I think, just out of curiosity, I'm here just to learn what you guys have to say. Thanks.
Thank you for joining. Definitely the sector needs new people, for sure. We have also Maria. Hi, Maria.
Yeah, hello everyone. I'm Maria Alvarenga. I am from Brazil, but I live in the Netherlands for 3 years now. And I work at AquaSuite at Royal Haskoning DHV. And I work with mainly the products for wastewater treatment and sludge treatment. And I'm a delivery engineer, so we prepare the configurations to optimize the set points for the plants. And I'm here also to understand more about digital twin and yeah, see how I can contribute. Thanks.
That's great. Thank you for joining too. We also have Luis Seminario. And this is the one before the last one. Hello, Luis. We'll go to the next one. We have Mariano Michael.
Hi.
Hi, Mariano.
My name is Mariano, so I'm also from Brazil. I have worked almost all my life in companies related to AMI system for water, electricity, and gas. And actually now I am looking at what to do with all the data I have acquired during all those years. So that's the reason for being here. Nice meeting you all, guys.
Nice meeting you. Thank you for joining. Well, so the objective of this session is to generate debate and to have an open discussion about how digital twins can actually help water systems cope with such big changes that happen during events like the pandemic that we're just living. And what I'll do is I'll show 2 pages just as a teaser for discussion, but the idea is that all of us start contributing, asking questions, contributing with ideas, and sharing their experience in what they've done in terms of digital twin in their fields regarding this topic. Feel free to go off topic as well if necessary. We don't have to stick necessarily to this specific topic, no? Okay, so I'll share these 2 pages, be very brief and open for discussion. So I'll say, well, this is something that pretty much everyone knows at this point after being in the SWAN conference. But what is a digital twin really? It's a replica of the real system that helps the operations basically experiment and improve the operations constantly, no? So at the end it's a copy of the real system that you can use for experimentation in real time. And what I'm going to show on the right side, it's the way that we build the digital twin in the operation of Valencia. It's a 1.5 million people city where we basically implemented a digital twin in the entire water system, including the more than 15,000 nodes that it has, no? So, for example, in this case, what we did, no, we integrated everything in real time in terms of SCADA data, IoT sensors outside of the SCADA, GIS, ERP, AMI, CIS billing, and all the other systems. We integrated them in real time into one data-centric platform so that basically we could make use out of it and then apply hydraulic modeling. We use artificial intelligence to make sure that all this data is cleansed at the beginning. And then on top of this, we apply the hydraulic modeling on real time so that we have, with just the input of 300 to 400 pressure and flow sensors in the system, in real time, the 15,000 nodes replicated in the whole system, no? And that's what, for us, the digital twin is doing. Obviously, it went through many phases, through many years. This is the state in which we are today, no? Which we have a virtual system that is telling us insights of the real system almost in real time, every 15 to 20 seconds. And the topic of today, which is how can this be used, how can this be leveraged actually to cope with situations like what happened in the pandemic, no? Hydraulically speaking, and I'm not talking about the health issues right now, I'm more talking about how hydraulically as a water system was disrupted by this pandemic. What happened, at least in Spain and in many other countries in Europe, is that overnight, the consumption patterns of everyone in the city, from industrial customers to domestic customers, radically changed, no? Domestic clients, basically, you can see here 2 curves, no? The blue curve is the consumption pattern before pandemic, and the orange one is right after the pandemic, yeah? So this drastic change in consumption over the day, together with pretty much zero consumption in industrial customers, changed the entire operation, the entire way in which the system was behaving. So how can we actually anticipate these changes in the network and anticipate what effects these consumption patterns, these new consumption patterns are going to have in the operation? That is something that was key for us to understand how the system actually was going to behave and what implications in terms of constant pressures in the system, energy savings, in terms of disruptive operations we were going to have, no? So that was the first point. How it helped us do that is it's thanks to the digital twin. So basically what we did in just hours, basically, we implemented the new plants, the new operational plants in terms of production plants in the treatment plants, pumping stations, network elements, so that we basically could continue operating and being efficient and not having disruptive operations. For example, this is an image that we have in the entire city, where every 15 seconds we have a snapshot of this image, which is the map of pressures in the system. By this new consumption pattern, we could have this new map of pressures in all situations that we were having now, and see if we were having any big changes in terms of pressures in this new situation that we never had before in terms of consumption pattern. So that was another way in which we were using the digital twin. The third way in which we were leveraging the digital twin is, as everyone knows, in the operation was highly disruptive. We needed to keep operators home as much as possible and keep the operation running. So what we did basically is we had to have a backup group of engineers that were capable of operating the entire system. We got a group of engineers that knew about the network, but hadn't been using it so much, and train them in a matter of 2 weeks so that they could basically face the most common situations in terms of outages or breakages. We did that thanks to the digital twin. They were trained at home and they understood what happens in these extreme situations, and what they have to do. And number 4 and last, basically, well, luckily we didn't have any emergency protocol, but what if during the pandemic we had an emergency protocol? Normally an emergency protocol tells us what to do to minimize the disruption in the customers. So we needed to reassess all these emergency protocols so that the most common emergency protocols were in place for the new situation. So this is how we, as Global Omnium, used the digital twin that we had implemented in Valencia to cope with this new situation during the pandemic. Now I'm going to leave it up for debate and either receive questions or for you guys to include, comment, and see how in each of your situations you have used digital twin to cope with a crisis like this one.
How big is the utility? I wasn't here during. I don't know if you've introduced it, but.
Oh, sorry.
What's the capacity?
It's a population of 1.5 million people. Okay. It's the third largest city in Spain. It's the city of Valencia. It's on the East Coast.
5 million. Thanks.
Yeah, no problem.
How many customers do you serve? How many connections do you have in general? How big is the utility?
It's more or less 700,000 connections.
Wow, that's
yeah.
huge.
And what was good is that having AMI, we have AMI in the whole system, in the 700,000 connections. So by having AMI, we have a lot more information that feeds back into falls back into the digital twin constantly.
What's the AMI?
Advanced metering infrastructure, smart metering.
Smart metering, okay.
Yeah.
So did you have operators work from home a lot during the pandemic? Because I don't think our operators here could work from home. We don't have the infrastructure right now, of course. But could you, if possible, go 100% with remote operations?
Oh, yes, that was one of the key points that we experienced within the pandemic. I was talking about how we use digital twin to not affect the customer, but digital technologies, which is not necessarily digital twin specifically, digital technologies can be used for remote working. And for example, what we did is the operators that have to go and basically maintain the network whenever there's work orders. We have a digital system to manage and optimize routes and manage the work orders. What we did is we basically set the system up so that everyone could go directly from their home to the job site. and they paired in couples so that the same couple would be working together for the whole pandemic, so that they could basically go from home to the work site instead of going to the office before. That was for the operators that were basically doing construction job. But the people in the control room from day one could 100% go home, because this is an application that is web-based, so they could go home and do all this from home, basically.
So you had 100% remote work during the pandemic, during the lockdown?
If you can consider remote work, maintaining the pipes in the field, that's remote, and it's remote in terms of they go home after doing that, but it's not 100% remote, no? Because you don't have to go to the office.
And how was, I don't know how severe the lockdown was in Spain. Was it very strict lockdown? Or
it was one of the most strict lockdowns in Europe, I think. It was by law, they didn't allow anyone to leave their houses except for going to the supermarket. And we got even fines for doing that. So it was pretty strict. That's why the operation was so disrupted. Yeah. Sorry, Masen, you were saying something?
No, I was not saying something, but I was thinking about at Vitens, we experienced almost the same, and I think utilities are getting very lazy because the behavior of our customers are very steady. At Mondays, they use always the several amount of water, and so we can control our system that it should behaved a week ago. But at this time, indeed, the water pattern is at Vitens was exactly the same, different as you showed.
Yeah.
There was one other thing. During television announcements of the lockdown, we faced a drop of 30% within 10 minutes. And the pressure became too high and several pipes broke.
Oh.
And afterwards, the consumption was much higher than before to overtake effect. But since then, every time there was an announcement on the television, we realized and we dropped the pressure in our mains. But there's no digital twin that can take that into account, I think. Because it's, well, you know it's getting there, but it's so erratic and so rare that you can never put it in a digital twin. How should you cope with that?
Yes, we had a very similar situation, which happened in Spain. 8 p.m. People went out in the balconies to cheer for the health professionals. They went out and clapped, basically. So we also detected this drop in consumption at 8 p.m. for like 10 minutes, 15 minutes, or something like that. No.
And how much was it?
It was actually, I can show you here because it was in the presentation.
Oh, that was the dip.
You see this?
But at us it was 30%.
Yeah, it was not that big as yours, so it didn't have these consequences that you're talking about in terms of breakages. So we didn't experience these kind of things. But yes, at the end, obviously, a digital twin has two engines. No, it has a AI engine that is basically learning constantly on what on what the pattern of the behavior of the people basically is, and is inferring what the consumption is going to be in the future. Yeah, so that is something that it combines. I mean, and this is how we put together our digital twin. No? The combination of AI with hydraulic modeling gives you a lot of power, because AI basically studies the past to infer the future, no? And basically tells, okay, the consumption patterns of my population, of my consumers, is going to be this tomorrow in the next 24 hours. And I know that because I learned from the past, and I know that it's going to be like that in the future.
And
for
that's
that.
the problem with AI. You're learning from the past. If something is happening that has never happened before,
Yeah,
it can't react on that.
that's true. That's the
Yes.
thing of AI. That's
Yeah.
why combining hydraulic modeling is incredibly powerful, because then when you have a situation that never happened before, like the outage of a main or a big earthquake, then you can see what is the effect of this thing that never happened before in the network, no?
Yeah.
So
Can I, hi everybody. Pablo, I have problems before with my microphone, but I think you mentioned during your presentation, can
hi
you hear
Luis,
me?
how are you? Yes,
Hi,
how
hi,
Luis?
hi everybody. Sorry, I had problems before with my microphone and computer. I think you mentioned during your presentation that, not sure that I caught you properly, just your model has pressures every 15 seconds?
Yes, every 15, 20 seconds, we recalculate the model.
Oh, okay, so you
with real-time
recalculate a
data.
model. Okay, and can I
Automatically.
ask, yes, and can I ask you then, do you mean you have data every 15, 20 seconds then from the field measurements?
It depends on the type of data. We have data that is connected to the grid from the sensors, and the SCADA data, it is every 15 to 20 seconds. Data
Okay.
from AMI is not every 15 to 20 seconds, no? That data is once a day.
And then I was wondering, because in here I have seen, models every 15 minutes, simulation steps 15 minutes, 2 minutes, sometimes 15 minutes, but at some point, which are the benefits? I mean, it's great having such a, but which are the benefits of having, a model, not is that recalculated, but having, those measurements every, I don't know, 15, 20 seconds. That's increasing so much the capacity of your systems, right? I mean, which are the benefits from an operational point of view, or I don't know, is there any well, I assume there is a benefit, but why not 2 minutes or 5 minutes?
Yes, so basically the capacity of the systems was more linked to the we have two parallel models. Now we have one that is very, very granular, that goes up to the client pipes, basically. That incredibly granular model, that one doesn't run every 15 seconds. We have a more of a like a simplified scheme that is the one that runs every 15, 20 seconds. And that one is the one that actually it doesn't occupy so much compared to the other one. And it's incredibly powerful having it in real time, because it allows us to see things in real time. So big things that happen in real time, if you let them happen for 20 minutes, then probably you're going to flood an entire city, no? So
so meaning that is the big one, the strategic one, right? The one that you have every 15, 20 seconds, right?
Yes.
So that's real time. Understood.
Yes. Yeah. And then we can, in that one, we can control the SCADAs with that one, basically. So if you have a problem that happens right now, you take 15 seconds to react. You don't take 20 minutes to react and close a big valve that could have caused something.
Understood. And can I ask you something else? And then I did, time for the other participants also to raise their questions. Maybe also for, sorry, the guy from the Netherlands. I don't know how to pronounce your name, but maybe you also, or for anybody also having a direct experience with real-time hydraulic models or digital twins. I think you mentioned, Pablo, that you have smart metering. Customers have, smart meters, all the customers or almost all the customers, domestic customers. I was wondering that may have give you such a in-depth knowledge of the consumption patterns all across the city, right? How have you, how have you brought that into the model? I mean, are you bringing that data as it is, or do you have developed, I don't know, 100, 200 different consumption patterns, and then the model is using those, let's say, normalized consumption patterns that you have identified based on actual consumption data?
Yeah, so I'll tell you our case. Maybe someone else here who has another case can contribute and tell you how they're using AMI data, no, in digital twin. But in our case, we've had AMI data for 10 years, for 12 years now, sorry. So what we have done is applied machine learning algorithms to this data to 10 years of history of data to recognize exactly the way that they are behaving, basically, recognize it and assign it to a type of client. Basically, we know if it's a restaurant of so much capacity or if it's not. But for each client in particular, for each client, we have an ongoing forecast of their demand, every single client. Yeah, so we know every single client for the next 30 days how they're gonna behave. That's what we use in the digital twin.
Okay, thanks.
Yeah. Anyone else wants to talk about how they're using AMI in digital twin and how this data is leveraged?
Yeah, I have actually a question, Pablo. I have been working with AMI for a couple of years also on the other side of the table, selling systems. And I was wondering what kind of outcomes you get with all this data. I mean, knowing the profile of the restaurant for the next months, I guess it's interesting. But for example, can you detect where there is some water losses or some leakages, tampering? What kind of outcomes you can get with that?
For specifically for the digital twin, you use it to calibrate the model much better. Yeah, the AMI data, and then you can beyond the digital twin. Obviously, you can use it for. I mean, in the digital twin, you can also use it for forecasting the behavior. You can know in the next 24 hours, for example, you know how your system is going to behave. So you know if your water tanks are gonna run low, or if there's gonna be a pressure peak in one point, and therefore you need to do something about it. Yeah, that's within digital twin. Outside of digital twin, you can do as much as you want with the data. We use it to, for example, find leaks in the system, not in the client, in the system too. Obviously in the client as well. Or to, for example, detect those meters that are trending down and are make you lose revenues as a utility. Yeah, even though their battery is still up, you're probably losing revenue, and then you have to change the meter. Things like that, no? Or like in Valencia and other cities, we have a connection with the Red Cross, with the government and the Red Cross, and whenever we have people that are over 75 years old, and they have a deviation in their consumption pattern, we tell the authorities, and they come and check on them. And sometimes we found, bad things for this. That would have probably taken weeks or months until we found these people in their homes. But this is the way that we're using it, no? To serve better the customer.
Can I add something? That's great. The only not problem, but the only issue I see is that there are countries or places where domestic customers do not have meters. So I cannot see, how in the future those utilities or network systems may have smart metering, because nowadays they don't even, they are not even built and they don't have meters, right?
Yes.
It will be interesting to hear from somebody how they deal with such a situation, right? How can you have an accurate model when you do not have what actually domestic consumers are consuming? Just because they don't have meters, or they are not built, or the meter coverage is very low, I don't know. But probably your scenario over there in Valencia is the ideal one, right? Or close to the ideal one.
Yeah, maybe someone else wants to speak about how to include modeling without meters. Otherwise, I'll give my opinion.
Well, I could say something. I would say that a meter at every consumer is not necessary. Of course, it's an advantage to have some metering, but you can often, in fact, you can use the model to find out where it's most useful to place meters in order to get the main behavior of the consumers.
Totally true. In our case, we started with manual reading, having the digital twin with manual reading, and some clients were not metered either, or some areas of the city. or even like, I don't know, public buildings, some of them are not metered. So as Morten is saying, well, you need to have assumptions about how the clients are behaving, but you don't need to have the metering in every single point to create a model.
Well, I can perhaps give a clue of how to calculate the consumption of different consumers. We are now collecting lots of data from every consumer, and we are comparing that with the annual usage. And we made a model out of the number of people living in a household, square meters they're living on, the size of their yard, the income, and things like that. And if you combine it, you get quite a good prediction model to calculate how much water is used per household. You can calibrate it on those meters you have. That's perhaps an idea to do it, and give an idea how much water is used by in a household. And we are doing this to make a reference for a household how much water they average use, so we can warn them if they are using more than average, so we can give them some advice to reduce the water consumption.
Nice. And are you achieving water savings in the population?
Well, we are only allowed to advise them to save. Okay. We cannot say just don't use. The government can say that, don't water your garden, but we can't. Legally, we are bound to our contract, and if they want to use lots of water, they can do it.
Okay, but so, have you registered any savings by doing these initiatives?
The problems until now was that the water usage until 4 years ago was dropping per capita, and now the last 4 or 5 years it's rising per capita, and that's a major concern right now. It's risen about 4 or 5% in total, and we expect that it will rise more.
Oh, wow! And can I ask you? I'm very curious. Why is that? Why is that? It is. I mean, the level of awareness about water in the Netherlands is very high, right?
Yeah.
So why is that?
Right.
Why are people? Are you talking about domestic or commercial or
domestic
everybody?
In this case?
Domestic.
Yeah. And we think the water consumption was getting lower because most of the equipment in the kitchen and for washing machine, things like that, they lower the water consumption, and we think there's a bottom in it right now. And for saving energy, a washing machine is now taking even more water to get the same pureness of the wash. So with a lower temperature, you need warm water, and water is cheaper. So they are saving energy. They don't save water.
Understood.
Yeah. That's perhaps one of the reasons.
Interesting, very interesting. Yes, you would see normally when you look at appliances, in general, you see that now they consume less water than 10 years ago, like toilets and all these things. But I didn't know that case about wash machines actually.
Yeah,
it's very interesting.
They received the bottom, the lowest level you can get, and instead of flushing once, they are flushing twice now. Because one time is not enough.
Wow.
To go back to the question of the 30% drop in consumption and the power problems in the network during the COVID announcements, I think perhaps the issue there is that the hydraulic models, they would actually be able to emulate this and actually be able to simulate this. The problem is that the digital twin does not contain social behavior and the TV programs and if there was a national football game or there was a big announcement or something that really affects the water consumption, that is not part of the model, at least not deterministically.
But if you have a model that's fed by data every, let's say, 10 seconds, it can be adopted. But that raises another question. do you allow that a digital twin is controlling your network? At VTens, it's not allowed. We can use our digital twin to calculate scenarios and to get the most optimal solution, but we are not allowed to use it as a control mechanism for the operation.
Yeah, but I think if you could have made it quite likely that it could have avoided the bursts,
yeah,
then someone might have listened when you suggested that it should control.
Yeah, actually, our system is controlled, but it's controlled right now every 5 minutes. So every 5 minutes, there's a data point coming in.
Yeah.
And in this week, they changed that into 5 seconds.
Ah, okay. And then you're approaching something which could be close enough.
Yeah, then it's near real time.
Yeah.
Then you can react more accurately and more swiftly.
And at the end, what AI allows you to do, it's these kind of events that happen every once in a while, and you wouldn't have detected them. Then you start detecting them, like I don't know, the Super Bowl and commercials there. I'm sure that if you start looking at the data, an AI engine is going to start detecting that there's a Super Bowl every year, and that the consumption drops for a certain amount of time. And you have to do something there. The question then is it going to detect like an earthquake that nobody would have detected before? No, it's not going to do that because that's totally random. But these kind of events like weekends, Super Bowls, World Cups, we start detecting them
Yes.
in terms of behavioral patterns.
Bank holidays is another one.
Yeah.
Yes. Can I add another? I would like just to ask something else to anybody. I think Pablo and sorry, I don't know how to pronounce your name. The guy from Vitens, or maybe
Mario. Actually, it's my first
hi,
name.
Mario.
Sorry.
Okay.
I was in Messen, which is might be your
that's
last
my
name,
family
right?
name. Yeah.
Okay.
Sorry.
Anyway, to you, but also to anybody who may have that knowledge or experience. I'm also interested, all the benefits the digital twins have. I think that's pretty clear. Just countless, right? But I'm also interested on, is there any unexpected outcome, positive outcome? I mean, that you have had, from having those digital twins implemented, something that you didn't think about, and then I say, hold a second, we even didn't think that this could be improved, or we will discover this, or this type of things. Anybody?
Yes, we had. Oh, okay.
Yeah. No, go ahead, please, Mario. I'll go after.
We are now working on some purification plants, and we do have a rather conservative way of the control settings, pressure, flow, and things like that. But now we are working on with a model on reinforced learning. And now the computer model showed that there is another type of control settings that they never thought about, which was more effective at the end. So from the experience of the operators, they were still keeping the settings they know, but they never thought about another type of rules to control the plant. It's just another local optimum, but a better optimum than they are using before.
Oh, that's wonderful, right? It's like even those people who plenty of experience, they even didn't think about this alternative way of doing.
Yeah, you're right.
That's great.
Yeah, I have 2 or 3 examples. Some of them are similar to yours, Mario. It's one of them is, for example, operators, when they fill the tanks to basically the gravity tanks to feed the city, they typically tend to fill it up to the maximum whenever they're not full. No, so that's something that always happens. What we did is we started using the calculations that we're doing here to optimize how the tank should be full, using demand and using electricity prices for the next day. And that basically allowed them to save between 15 and 20% in energy. and they were not having the tanks full all the time. So that that was something that was against their rules, but at the end saved that. Obviously, it took us a long time to implement it because it was against their belief, and that's something that you need to break. No, that's one example. Another example is we had an area of the city that didn't have any pressure sensors. It was small, but it was an area of the city where we didn't have any pressure sensors, and we didn't know that there was a really high pressure in that area. But there was a high pressure. There were a slightly higher level of leaks in the system, but nobody complained, obviously, because customers, when there's a high pressure, they don't complain. So when we started putting on the digital twin, we realized that in that area, basically, the pressure was between 20 and 25% higher than the rest of the network. So we went there and installed a VRP, basically, to lower the pressure. And indirectly, we reduced the number of leaks in the system, improving the non-revenue water. No? That was another funny outcome of the digital twin that brings you. And the third one, which is funny too, is we realized that there were valves that were closed and we didn't know. That's funny, but at the end you realize of those things when you calibrate the digital twin in real time.
Yeah, the last one is indeed famous. I recognize that.
Yeah.
I have a question. So when we're talking about digital twin, it's mostly around distribution systems rather than treatment or water quality. And is there a specific reason why there's much focus on this over modeling our distribution systems over water treatment plants or things like that? Other aspects.
Yeah, there's digital twins for everything. We have for the sewer network too, for the sewer systems, for example, we have another one. But the water systems are the one in which the modeling has been more developed, I would say, and more tested. So like we have like really advanced hydraulic models that allow you to set the rules and highly calibrate your system to levels of, above 90–95%. Which is something that in like wastewater treatment plants, for example, where you have to mix biological processes, it's a little bit hard to calibrate it to those levels. And that's why I would suggest that's why they're not being so widely used. But I will let Mario also speak about this because
maybe I'll chime in just with a point. We have so again, I have a small company that has some digital technology, and one of our clients is a water innovation center in the Atlanta, Georgia area. And they're an innovation center for water, but they're a subsidiary of the Department of Water for Gwinnett County, a fairly large water operator. And one of the projects we're doing for them is we're integrating their operations data coming from a SCADA database. We're pulling that into a data warehouse that we built for them, and then we're also pulling data in from their lab data, from their dosing records, and so forth. And that way they can, and they're going to feed that to an AI system that is as an experiment to see if the AI can predict how they can optimize their dosing to reduce costs. They think that they may be able to reduce costs per year by as much as $200,000, maybe even a little, maybe even 300, maybe even more, and so forth through optimizing the dosing. So, I think my sense, and Pablo and Mario, I think you're more expert than I am, but my sense is that for distribution and transport, digital twin is much more evolved. But what I see is that there's lots of things beginning to happen in the other dimensions of operations, such as in dosing. But it takes the integration of data more because you need all the different sources. You need, in this case, with this client, you need the operations data. You also need the dosing data, and you have to be able to bring that data together and have it be all in one place. And that takes a lot of expense and a lot of preparation. And it's easy for that to go wrong. Also, it takes a lot of expertise and data to make sure that you don't damage the data when you do that, and the data has integrity and quality. So I think I think it will get there, but it's just kind of starting to happen now, basically, for digital twin, these other dimensions.
Can I add some? sorry, can I add something? It's like the way I see it is that when it comes about networks, the distribution of transport, we're talking about hydraulics, right? And the fundamental laws of hydraulics are pretty simple, right? In comparison to treatment, water treatment, or even wastewater, where we have biology, we have physics, we have hydraulics. Let's say that the dimensions of the problem are many more. So for me, yeah, digital twins and hydraulic models linked to digital twins, obviously, you know, water transfer and distribution makes sense, but the more complex the system is, the bigger the potential of a digital twin becomes. And in that sense, I will see probably in the Netherlands, I don't know, or in some other places, they have so many projects going on in water treatment, right?
Not only water treatment, also drinking water treatment.
Yeah, yes, drinking water
not
treatment.
Wastewater
Yes.
treatment, but what we are doing now is trying to model our treatment plants. And since we are using groundwater, the initial groundwater quality is quite stable. But we are using several wells, and the wells are having a different water quality. So the water quality getting in is changing continuously. So for decarbonation, for instance, you have to adapt the amount of sodium hydroxide or other chemicals to decarbonize, and that can now be adjusted to the kind of water that's pumped up. But some things that are quite difficult to model is, for instance, sand filtration. And we do have some models that can calibrate sand filtrations, but it appears that every sand filter is unique. So you have to calibrate every sand filtration unit separately. So that's our problem until now. But the main things like aeration and removal of methane, decarbonization, that can be modeled quite well. And we do that with a combination of an EPANET network with FreakC. FreakC is a chemical model. And then you can calculate every chemical reaction in it.
So we need to, we're finishing the session in 20 seconds. The session will switch off automatically. Thank you so much for your contribution. It's been a really good session. Hope to see you all around sometime in person.
Okay.
Thank you, Pablo. Thank you, everyone.
Thank you very much.
Well, I have to come to you to Valencia once.
Yeah, you should.
Utilized before to earlier today to join the event. And if you can't find that link, you just check the chat box and it'll be there for you as well. So go ahead and link over. We're going to take a 5-minute break as we do that. And then when we come back, we're going to get started with panel 3. So I will see everybody again